I'm Mark Carlson. I'm with Toshiba Memory. Paul and I were going to give a talk on this Endurance Group Management. It also includes NVM set management. When NVM sets were introduced, an Endurance Group were introduced with 1.4 of NVMe. It's rather limited in the fact that the SSD manufacturer is going to ship a drive pre-configured with NVM sets, and as a customer you have limited capability of actually saying where those sets are and how big they are. What we're doing with this new work is allowing much more fine-grained control over NVM sets and endurance groups. 1.4 has endurance groups, but it's the drive telling the host what's being wear leveled by the drive. And as a result, the host has to wear level across sets in some cases, and it depends on what the manufacturer shipped you. So we're adding some more capability here in that space. I'm not going to do the abstract. That's a nice little picture of us, and get right into it, right? So some of the use cases include more flexible I/O determinism, like I just said. Instead of getting a fixed configuration from the manufacturer, now the host can have a little bit more control out of how things are laid out, what media is going into which set, and what is the responsibility of the drive versus what the responsibility of the host is. You could think of it as a dial that you can turn all the way to one side and have the drive do all the wear leveling. Or you can turn it to the other side and have the host do all the wear leveling, or you can kind of chunk it up in the middle somewhere. So that's what we're doing here is having a fine-grained knob that gives the host more control. And this is a big deal for some large customers. And eventually, the reason you're doing this is you want to divide the capacity of the drive. The original goal of the I/O determinism, remember, is, as Nick said, to eliminate or isolate the activity between these different chunks of the drive. If it's all one big chunk and you're talking 40 terabytes, you have, umpteen different applications all hitting the same media. And the other thing, sort of from a selfish aspect of a drive manufacturer, is we don't want to ship different SKUs for each customer. We'd like to have one SKU that we ship, and the customer configures it the way they want. So that's really, the motivation for the drive vendors to implement this is that they don't have to have, different configurations for different customers. So what are we talking about here? So namespaces are, contain some sort of array of logical blocks. In the future, it might be key value kind of namespace. And of course, Dave talked about zone namespaces as a different way of getting logical blocks in there. And then the enclosing namespaces is something called NVM sets. So within an NVM set, you can have multiple namespaces, or just one if you want. And then enclosing sets are endurance groups. And again, you can have multiple sets in endurance group, or you can have a one-to-one thing, all right? And then not introduced in this work, but in work that Fred's doing, is domains. And that allows you to have multiple endurance groups or one endurance group and then domain. Typically, individual SSD might only have one domain, whereas a huge room size NVM device might have multiple domains and then multiple failure domains as a result. So if you look at the old NVM sets, what we would do is align them according to the channels within the drive. And so we connect these media units by channels, and then an endurance group would be pertain maybe just one set. So the key on the right there is this new concept called media unit. Media unit Could be a die, could be something smaller than a die, could be something larger than a die, but it's kind of the smallest granularity of NAND or persistent memory that the drive is wear leveling across itself. It's capable of having this small and no smaller wear leveling. So if you combine them, multiple media units in a single endurance group, that means the drive is wear leveling across all those media units in that endurance group. But on the other hand, if you have multiple endurance groups, that means a host needs to wear level across endurance groups. And this was the original intention of endurance groups, is to push some of that off into the host and have him determine whether he wants to wear level the entire drive as a whole, or if he wants to just take it as each set gets wear leveled by the drive. So, and originally this was again from I/O determinism. You want to create sets according to the capacity requirements. Some customers have applications that have a working set of 1 terabyte, for example. And so they'd like to create NVM sets of 1 terabyte or smaller. And so the drive level, the drive is wear leveling within a set here, and you have 4 endurance groups and 4 sets. As I said, the host is going to have to wear level across these sets and endurance groups if he wants the entire drive to wear out at once. And the configuration of this is typically done at the initial deployment of the drive. Now, you may repurpose a drive and reconfigure these sets, but for the most part, it's done once and done. And then what we've done is have several different configurations of endurance groups and sets that you can pick from, and these are known supported configurations from the drive manufacturer. Eventually, we may get to the point of you being able to read and write a bingo card of any configuration you want, but for now, that's a testing and qualification nightmare for the SSD vendors. So we backed off from that, kind of configuration. And, drive might only still support a couple of different configurations, such as a 0.5 terabyte and 1 terabyte sets. So this isn't really a limitation on what the drive can do. It's, whatever the customer wants, we'll ship to you, of course. Right, Lee? So what if the host wants to do all the wear leveling, right? You can have a configuration like on the one on the right here, where each endurance group contains 1 set and 1 namespace. That means the host is essentially doing all the wear leveling here, right? He's going to come in and determine what the wear is on each of these little media units, and he's going to notice that one is being worn out more than the other, and he's going to start using other media units instead of the one he has been using, right? And this could be an ideal configuration for zone namespaces, for example. Each zone namespace then has its own wear information that you can use to determine whether to keep writing to that zone namespace or start moving off to something else. And then there's all sorts of configurations. Again, if the drive vendor supports these different configurations, he'll put it in the configuration table for you to pick from. And so one SSD can use some media units for a small amount of fast capacity, and the remaining units for much higher density. If you have a set that goes across channels like this, you're going to get better bandwidth. And if you want bandwidth, that might be the way to configure it. If you want isolation, it's not such a good idea because every single write is going to contest for those channels with other media units. All right, now Paul's going to take over and tell you how we did this.
Okay, so before I go into the details of how we'd expose the organization, I'll talk about a different use case, which is from storage systems. If your NVM subsystem is a room full of racks, then you are probably not going to be working with individual media units. Instead, what you would really like is the ability to create and resize endurance groups and NVM sets simply by specifying how large they should be. So this is what we're calling capacity endurance group management. These names may change before the final technical proposal comes out. The main point is that you'll have this domain which contains controllers and will also contain a certain amount of non-volatile media. That's a concept that's been brought in from the domains and partitioning proposal, which is about ready to integrate. So the capacity will be from whatever storage there is. You know, in a large storage system, it could be SCSI disks sitting back behind, and these are presented by the storage system as, you know, a namespace striped across whatever kind of media you don't know. There's also the ability to create an NVM set inside the endurance groups, and then to delete NVM sets and namespaces and endurance groups. So where we've arrived is that, and I gave you a little bit of a preview, there are two methods. One is the direct endurance group management, where you will, the host will take a look at the offered configurations and choose one of those by specifying its name. The other is what I just talked about, capacity-based endurance group. Give me an endurance group of this size, give me an NVM set of this size. So direct endurance group management is intended to be used for drives. Basically, like I said, it's a fixed set of configurations. And at this point, typically, choosing one configuration will be for the lifetime of the drive, because things get very complicated if you use up capacity for a certain amount of time. Then you want to reconfigure it because you may have some media units, you know, think dies, that have different levels of wear. And if you're not careful when you reconfigure, that could be problematic. So that's something we've sort of punted to some future version. And I'll point out that direct endurance group management does satisfy the needs of the hyperscalers. But what we're going to do is choose an entire configuration at one time, rather than configure one endurance group, then look at what's left, configure another endurance group. So that'll not, again, that's something that will not be in the first version. So we are currently calling this the Endurance Group Management Command. Again, that name may change. There are two types of operations. One operation is the select media unit configuration. Like I said, that selects one of the specified, or rather one of the indicated configurations that the drive tells the host about. On the other side, for storage arrays, there is a set of 4 operations. Create an endurance group, create an NVM set out of, again, a specified size out of a specified endurance group, and then delete an NVM set, delete an endurance group. When you delete a NVM set, it automatically deletes any namespaces that may still be in existence. Now you can create an endurance group, then create NVM sets within that, and then apply the existing namespace management command to create namespaces within an NVM set. But if you delete an endurance group, you take away that, all of its NVM sets inside of it, and any existing namespaces. So that's sort of the direction that we are going. Okay, how do you describe these configurations that you could organize an SSD into? Well, we are, if you think back to that, the picture that Mark had showed, where you have an endurance group containing one or more NVM sets, it's going to follow that. The highest level piece for any particular configuration is information about an endurance group. It's the endurance group configuration descriptor. What's the information you get on that? Well, there's the capacity adjustment factor, which is a concept that we borrowed from UFS, and that's what allows us to specify that you want this endurance group to operate as, for example, TLC or QLC or as SLC, capacity adjustment factor. It's sort of the ratio between how much capacity you're going to burn up to get how much actual NVM capacity you're going to have to use to get the specified capacity for that endurance group. There's the total endurance group capacity, there's spare capacity, a concept brought over from smart data, and then some sort of endurance estimate. How much more lifetime does this have? Okay, then this endurance group will have some number of NVM sets inside of it, one or more, or possibly just, yes, it would have at least one NVM set inside of it. And then, again, you recall the picture we had a controller and then a number of channels coming down off of that. So what are the channels that go into this endurance group? If you remember the vertically partitioned one, which was the IO determinism example, you have a single channel going down into this endurance group and a number of media units off that, then another channel over here, and it's into a different endurance group. Or you can stripe, as Mark showed, stripe the endurance group all the way across, and so each channel can be used in every endurance group. So there are a list of channel descriptors, and then for each channel, a list of the media units that are accessed through that particular channel. When you come down to the lowest level, the media unit status descriptor will have an identifier of which domain it's located in, and then what endurance group is it in, what NVM set is it in, the capacity adjustment factor, which is inherited from the endurance group, and then characteristics that come from the SMART description, the available spares, percentage used, and then the number of channels that are attached to a media unit. Now, right now, I haven't heard of any products that would actually have two channels talking to a single die, but we're trying to be flexible for the future. Now, to turn to what we need to satisfy the storage array folks, it's the other model, the capacity endurance group management. So this allows the host to dynamically create and delete endurance groups and NVM sets. And it doesn't really have to care about whether you have SSDs or spinning Rust sitting behind those. So here's the command. And what I want to talk about now are the lower parts. Let me get a little pointer here. I want to talk about the operations for storage arrays that I've already summarized. Create endurance group, create an NVM set. Again, for both of those, you give a size. Delete an NVM set, specify which one, and delete an endurance group. Okay. I'm almost at the end, so we'll have plenty of time for questions if you want to go through any of these details. But right now I want to talk about what are the things we're not trying to cover here. One is error correction. As the gentleman from NetApp has been reminding us, if he doesn't have any indication of how much redundancy is available inside that SSD, he's got to build redundancy at a higher level and stripe that across the disks that he has access to. What degree of error correction is available inside the SSD? This is something that we don't know. We tried to figure out a good way to represent this and decided there are too many variables, so we just decided to push that off to the future. So once we have more experience with understanding the representation of the storage inside an SSD, then we can come back and address these later. Second bullet is what if you want to incrementally configure the endurance groups inside a single SSD, rather than select a single configuration that'll nail down all of the die all at once? This is something that is going to take some thought. We don't know how many people would actually use this, so that's deferred to the future. Something I alluded to before is reconfiguring. What if you use the SSD for a while, you get different levels of wear on different media units, How can you repurpose that drive for possibly a different configuration? There are a lot of complexities involved in understanding the wear done in, for example, the amount of wear in an SLC mode for an endurance group up here versus the amount of wear on the die that were being operated in QLC mode. It's highly non-trivial, as one of my professors used to say. So again, that's something that's being deferred to the future. Okay, so we've got this abstract concept called a media unit. Well, there are a number of different levels of organization. A media unit wouldn't necessarily be a die. It might be a plane. It might be, a couple of die. So will it make sense to be able to specify some lower levels of organization below the media unit? We've got to see. So if we do this, it'll be in a future proposal. And then finally, what do you do about mapping of zones to media units? Is this something that could provide any benefit? There are a lot of complexities there that we haven't even begun to talk about yet. So this is some of the stuff that'll be off in the future. So I guess now we're ready for questions.
So you mentioned that you punted doing reconfiguration for single SSDs, but you seem to allow reconfiguration for storage arrays.
That's right.
So don't storage arrays present the same problem of the history? If you delete an endurance group and want to repurpose all of the media that's in an array, you have to know the history of the underlying media.
Yes, that's right.
Well, when you say history, you mean where? Yeah. And so we have a where property on each media unit that you can go and look at and put together, maybe a not-so-worn endurance group.
And I'd like to point out that right now what storage arrays do, if they're composed of individual SSDs, they can go look at the smart data to find that out. Would the gentleman from NetApp care to elaborate on any of that? No? Okay.
He doesn't have a mic anyway.
So,
That's right.
So I'm going to be mean and ask the first question I think that everybody wants to really know. Is this going to kill, zone namespace going to kill open channel?
I would say no, definitely. I think what I tried to show in the talk is that there's new use cases emerging, right? And there are still people who believe that a substantial, very significant people in the market who believe that we need the open channel kind of model. So I don't think this is us or them, or it's both. ZNS is a way to deal with a particular use case where people wanted a streaming, sequential write model. It's a particular thing, and we thought it was big enough to peel off and create a device type for it. That's essentially it. But it won't quote kill open channel.
And keep in mind that knob I was talking about.
Yeah.
Open channel is the knob all the way over here, no control. NVM used to be the knob all the way over here, no control. What we're doing is giving the host the flexibility to turn the knob in different directions,
Right.
and it's much more powerful than just one or the other.
A comment about this same topic about open channel versus zone namespaces. The way I think of it is that zone namespaces is just a reformed, not just, I didn't mean to sort of minimize it. It's a reformed version of open channel.
Can you get nearer to the mic?
Okay,
Yeah.
it's sort of like
Eat the mic.
Okay. So zone namespaces I see as a reincarnation or reformed version of open channel, which abstracts certain things. Maybe for example, that the drive can still relocate a zone while keeping the same zone ID. So it can do zone level remapping as opposed to doing fine-grained remapping. And that might provide some benefit and some, for example, that might allow the drive to do wear leveling by itself without it being visible to the host.
Right. right?
Is that a good way of thinking about it?
I agree more or less with pretty much with what you're saying. The way I think about it is, to me, zone namespaces, or the zone block model, is where we have a collaborative FTL between the host and the device. So the device is still doing garbage collection and wear leveling, and and the host has its own FTL that it's in the file system or in the host layer. It's doing some garbage collection of zones, and the two are collaborating. Whereas in the full open channel model, it's really all of that functionality is gone from the drive, and the host is doing everything. So I see it as kind of a different use case, not an either or. So.
You had mentioned that you were using UFS as the inspiration for file system work on this. What other file systems have you using for influence, and what file systems do you see being used on each platform, OS as in Linux, Windows, whatnot?
Well, my mention of UFS was specifically only the scaling for QLC versus SLC, the capacity adjustment factor. That is the only thing I was talking about. So in there, it's the ability to say if you're going to operate a cell in SLC mode, when that same cell is capable of operating in MLC, TLC, QLC, you need to provide a scale factor for how much capacity you're going to chew up to operate in SLC mode, because it's up to 1/16 of the storage you could get if you're operating in QLC. But that was my only point from UFS. It was just a single formula, basically.
Yeah, I was wondering about the host managed mode, where you're turning the knob all the way over to the host. If you have a power failure, you're going to probably brick those drives, are you not, if you don't have a way to restore all the information you have in your FTL on the host side? You need some NVRAM or something.
Are you talking about host managed ZNS?
Yeah. If it's all host managed, then you need some NVRAM or something on the host to keep track of that. If you lose a power failure, you're going to break all your drives, right?
Well, I mean, we're not sure I can give you a perfect answer on that. Maybe someone else can. We're working on the power fail models. I mean, and what can be recovered from a zone and what state the zone is in, et cetera. So I think there's ways to manage it, but I know there are ways to manage it, but I'm not sure I can answer your question explicitly.
Well, he did mention that there's going to be a lot more DRAM, and if there's more DRAM, then you need more capacitors.
There's going to be less DRAM.
Yeah.
Right.
I'm saying there's going to have to be some hardware solutions to this. It can't just be all software and magically it works.
Yep. And any advice from the host that the system's going down would be much appreciated.
Yeah.
Okay, so I'm still trying to wrap my head around the difference between NVM sets and endurance groups. So I take it that an endurance group can have one or more NVM sets within it, but what does it enable? So,
So the NVM sets were a way to sort of achieve isolation between two different NVM sets. We're softening that a little bit with this latest. Yeah. So you can see with that kind of configuration, they're isolated because each set is on a different channel. So when I write to one set, it's not conflicting with another set. So I can take a single drive there and have 4 applications hitting it simultaneously, and each application doesn't see any interference from the other application's work. An endurance group is just a way of saying, what is the drive wear leveling by itself, right? Which means that the host, if in this case, has to wear level across these endurance groups if he wants the entire drive to wear out at once. But that isn't the only policy for wear that a host might envision. He might actually hit one of these NVM sets more so it does wear out, right? So then he can move on to the other sets.
And I'd like to add, I think where you're going is, why do we need this extra level of abstraction?
Yes.
Why is there a need for multiple NVM sets inside one endurance group? And the answer is maybe not. I've heard one person say that she had a use case for that. Possibly it was not necessary, but it's where we are. It's where the I'm losing the term, but the predictable latency mode is expressed per NVM set. So in theory, you could have an NVM set, two NVM sets inside one endurance group, and they're in different phases of whether they're, well, actually even that one wouldn't work. So perhaps that was a little overreach.
In standards, we sometimes put in flexibility just to get somebody's vote.
Well,
So we can pass the damn thing.
One other thing I would say is when we were first developing NVM sets, which was prior to endurance groups, so we were developing the predictable latency mode and sets, and we were trying to have a model that didn't enforce that sets would be a hardware-based concept, that it could be virtualized, it could be hardware. We didn't want to freeze that in the definition. In the end, we needed some way to tie to the hardware, to the capacity for wear leveling. So you're going to wear level across these resources, and we created endurance groups. Maybe if we were starting from scratch, we could get away with only one of these concepts. And I will say, I was going to answer the question by saying, like Paul did, I haven't seen an example in the wild yet where we have multiple sets inside one endurance group. It's usually a one-to-one, and it may stay that way. We don't, but
Yeah.
My question is related to this concept of I/O determinism and this endurance group trying to visualize the parallelism inside the SSD controller so that we get granularity at the die level possibly. Having said that, don't you think this actually enforces more challenges in FTL design because essentially the FTL really doesn't actually work at the die level, and the data and the metadata, they are actually not that easily separated, and so unless the FTL really separates the data and metadata, how will this actually work in principle? That's the question.
So the FTL has many different aspects, right? We're only addressing wear leveling here, right? We're not addressing garbage collection. We're not addressing performance or amplification necessarily, but these things do help, right? But the whole use case of moving some of that wear leveling off the drive is that I can wear level at a system or even a data center level this way, right? I can decide where the wear is going to happen in my entire data center at a pretty fine granularity now. And so that's the use case, right? Moving the FTL out of the drive with just the wear leveling aspect is a big help for these data center-wide customers.
And I'd like to point out two things. First, that we actually have 7 minutes left.
Okay.
The other is, when you use this model, it's on the screen, the host has to assume responsibility for wear leveling across those. And it's entirely possible that the host can, basically burn out one of those endurance groups. This is going to require a change in the warranties to make this explicit. Because we drive vendors, if we do what you tell us to do, we don't want you coming back and saying, I didn't understand. That's a little bit snarky, but that is one thing that you need to be aware of when you start operating in this mode. Did that really so has all this answered your question?
Not really.
You need to explain your question better.
2 minutes, please.
I think the question really was, let's say we try to envision these NVM sets across the dies inside an FTL, right? So the metadata in FTL, that is the, you can say the logical to physical mapping. Typically that is, unless we have actually, let's say we partition FTL into 8 parallel NVM sets, we don't run actually 8 parallel FTL threads inside the SSD controller. So essentially, the concept is that one write to one NVM set doesn't intersect with the IOs going in the other set, right?
That's right. In the example
concept.
up there,
Yeah,
the maximum bandwidth you'll get at one time into one set
but-
is less than a little less than a quarter.
But the metadata inside the FTL,
Yeah.
unless we create like completely parallel FTLs, I see there is a intersection across the sets that will happen, and this is my.
Yeah, and what I have to emphasize is that NVMe is an interface spec. How you organize your FTL that's an implementation detail that we do not want to try to dictate. And there's room for cleverness there.
Yeah, and there's a very healthy debate going on about how much flexibility should be enabled, right? That's one of the essences of the open channel versus more traditional SSD implementation. So the spec is enabling some models, which are definitely going to affect and may be inefficient. Well,
I see open channels easier because the FTL is already pushed to the host. Here, because the
yes,
FTL is
we're
still,
kind of trying to straddle the middle in some ways, but we're trying to make NVMe grow to enable these use cases. But that may make, for example, we think that the market will figure out, like, it'll develop ZNS drives, and it will develop traditional drives, and it may develop an open channel-like drive that uses the NVMe interface extensions that are being talked about for Endurance Group Management. But we're trying to build NVMe as an umbrella that can handle all the models instead of having all this fragmentation off. So
ZNS for me is a way, imagining a drive where I only have one Endurance Unit 1 NVM set in the entire drive, yet I'm using ZNS.
Yep.
For me, that's so that the file system is responsible for garbage collection and the drive is responsible for wear leveling. And
yes.
That's very clean,
that's
very
how
nice abstraction.
I think about it personally,
Right.
and I think most early adopters are.
Now, my question is, I don't know whether this gets discussed much, but what is the view on what the target zone sizes are, zone capacities, related to the physical resources inside? I personally...
Talk to your vendor.
Yeah, I'll talk to my vendor. Thank you very much. Well, in order to get uniformity in terms of how these things get used, there needs to be some, at least, consistency in model. And maybe that happens by a few of us talking to all our vendors.
Yes, that's what will happen.
Right. What Mark said, I think is fine.
Thank you.
Yeah.
So one complaint I've often heard about Open Channel is the amount of RAM it uses per terabyte of drive storage. What is the approximate amount of RAM that we will be needing to use on the host for every terabyte of storage?
David, did you want to answer that question?
The answer that I gave was depends on how you build the system. The question could be answered if you decide that at the next level up you want to re-implement the FTL. They showed a number of other models where your mileage will vary.
So what would be the worst case and what's the best case then? Need a number.
The answer is it depends. You're not going to get a more concrete answer out of
It's
it.
too early to answer that definitively. And
David,
it
what's
does
your
depend.
question?
And it does depend.
David Black, well, what I got up to actually to give Paul some props for a use of endurance groups that wasn't mentioned here. One of the things that endurance groups does is it ties IO stats to the media as opposed to the controllers, and Mr. Suhler up here did all the heavy lifting on the endurance group log page to make that possible. Thank you.
Last question.
Our stream, NVMe, so we got had sets and streams. Now I've got NVMe namespace. Are streams dead? Did I get?
Great.
Sorry,
Yeah.
Dave, what'd you say?
You're asking for political opinion from
No,
the
I'm
panel.
talking about spec. I'm talking about next version of spec.
We have not deprecated them, and there is no plan to deprecate them. But will they continue to be used? No, we'll see.
I don't know. Is there a need? Anybody want streams? All right, there's your answer. Thank you very much for coming.